In section 8.4, we're going to talk about compositions of isometries. Looking at your essential understanding on page 532, it says right above that, the term isometry means same distance. An isometry is a transformation that preserves distance or length. So translations, reflections, and rotations are isometries. You can express all isometries as compositions of reflections. Expressing isometries as compositions of reflections depends on the following fact. Here's your fact, your key idea. The composition of two or more isometries is an isometry. So, for example, if you reflect a shape twice, or you reflect a shape and then translate it, or you rotate a shape and then translate it up 5 units. Since you are doing more than one transformation, and those transformations are translations, reflections, rotations, any combination of those is called an isometry. Now, there are 4 kinds of isometries. If you look at these shapes, or these translations, you can see that the letter R in the first example has been translated. Now, if you look at it, it's been slid 1 unit or so many units to the right and then moved down. So there's 2 translations here. Because there's 2, it's an isometry. A rotation, you can see it there, it has been rotated. And then a reflection, it's been reflected and then slid to the right a little bit. And then a glide reflection, which it says you'll learn later in this lesson. A glide reflection is when you glide it or translate it, you slide it, and then you reflect it. So it's a translation and a reflection. On page 533, at the top, it talks about our next key concept, reflections across parallel lines. A composition of reflections across 2 parallel lines is a translation. So it's easier if you just look at the picture first. You'll notice that lines L and M are parallel. You will notice that triangle ABC has been reflected over line L, and then it's been reflected again over line M. Well, if you notice the red dotted line, all this is just a translation. The ABC to triangle A double prime, B double prime, C double prime, all that's happened there is a slide, is a translation. So here's how you can write it. So on your key concepts on page 533, we're going to actually go over how you say this. So here's what it says. I'm going to write it down first. It says R sub M, and then composite, R sub L, and then triangle ABC, triangle ABC equals triangle A double prime, B double prime, C double prime. And then it also gives you another way, which looks like this. Now you're going to need to study how to say this stuff, because this is not going to be the easiest thing. So here's how you say it. You would say the reflection over line M following the reflection over line L of triangle ABC is equal to triangle A double prime, B double prime, C double prime. So the reflection, capital R, over line M, because this is what you're reflecting over, following, not followed by, following the reflection over line L of this triangle equals triangle A double prime, B double prime, C double prime. Now I want you to look at the picture. What line was it reflected over first? It was reflected over L first, then M. You do not do this first. It says the reflection over line M following this. So you have to actually do the reflection over line L first, and then what follows that is the reflection over line M. So if we look on page 534, practice 1 and practice 2. Practice 1, it says to find the image of each letter after the transformation. Here's the transformation. Reflection over line M following the reflection over line L. So we have to do this first. So we're going to reflect it over line L. Now, obviously, this is not going to be the best drawing, but if you reflect it over line L, you would get that. Now, please keep in mind that any point that you have, like if you connect this point here with this point, or these pieces of the F together, or the bottoms, they would all be perpendicular to this. Now, something else you might have not known is that parallel lines, when you see these little like red arrows, that means they're parallel. So what we just did is we reflected F over line L. We now have to reflect F over line M. So it would look something like that. And once again, this is not the best drawing, but if you reflect it over line M, you would get that. Now, if you'll notice, from the first F to the image, all that is a translation. Okay? So let's do number 2. Number 2, we know that these lines are parallel, and we want to reflect the letter M. Now, if you reflect the letter M over line L first, it would look something like that. And then if you reflected this again, it would look like that. And your original letter to your image, you'll notice, is just a translation. And to review the key concept we just learned, a composition of reflections across two parallel lines is a translation, and we just proved that. If you have two parallel lines and you reflect something twice over those lines, you are just going to get a translation. On the bottom of page 534, our next key concept talks about the reflection across intersecting lines. It says that a composition of reflections across two intersecting lines is a rotation. We just talked about reflections over parallel lines. Now we're going to talk about reflections over intersecting lines. So a composition, when you reflect something over two intersecting lines, it is called a rotation. So if you look at the picture that's given to you, look at the picture as I explain this. Triangle ABC is reflected first over line L, and that gives us triangle A prime, B prime, C prime. That is then reflected over line M, and L and M are intersecting, and that would then give us A double prime, B double prime, C double prime. You will notice that the final image is a reflection of your original image of triangle ABC. So in this problem, the figure is rotated about the point where the two lines intersect. In this case, the point of reflection, the point of rotation is called point Q. So let's do the got it problem. In the got it, it says, use the diagram below. What is the reflection over line B following reflection over line A of point J, or of J? And then we have to find the center and angle of rotation. So the first thing we're going to do is rotate this letter J over A, line A. So if I folded line A, I would get something that looks like that. If I now reflect that letter over line B, I would get something that looks like that. Now, what I want to know is the center and angle of rotation. So the center of rotation is point C. Point C is the center of rotation. This shape went over here. Now, it went twice, so we have 45 degrees. So we reflected it twice, so you're rotating it. So if you reflect it twice, once 45, another 45, that means the angle of rotation is 90 degrees, and notice the position of our arrow. This arrow went clockwise. So the angle of rotation is 90 degrees clockwise. That's part A. Part B then asks, use the results in part A. We then have to make a conjecture about the center of rotation and the angle of rotation for any rotation that is the result of any composition of reflections across two intersecting lines. Sounds like a lot. Let me just tell you, here's what it is. Whenever you have intersecting lines and you reflect something twice, you get a rotation. The center of rotation, here are your conjectures. I'm telling you this right now. The center of rotation is the intersection of the lines. So by looking at this picture, line A, line B, intersect at point C. That's how you always get the intersection of point C as being the center of rotation. The angle of rotation, I'm going to abbreviate, the angle of rotation is always two times the measure of the angle that's formed by the intersecting lines. 2 times the measure of the angle. So if you look here, we have 45. That's the acute angle. That's the angle that's formed with the two intersecting lines. You just take twice that, and that gives you the angle of rotation. So if this was 30, then the angle of rotation would have been 60. If this was 20, the angle of rotation would have been 40. Now we're going to look on page 536 in the gray box in the middle of the page. It says that any composition of isometries can be represented by a reflection, translation, rotation, or glide reflection. Here's a vocab word. A glide reflection is the composition of a translation, which is a glide, that's where you slide something, and then a reflection across a line parallel to the direction that you just slid something. So it's important to understand that you are sliding it and then reflecting it. But the way that you slide it, the way that you translate it, has to be parallel with the reflection. So if you look at the paw print on the right, it has been slid up or translated up and then reflected over the line of reflection. And notice the way that it slid and the line of reflection are parallel. That is called a glide reflection. In the got it problem, I want you first to graph a triangle TEX. And we're going to make the triangle TEX, we're going to set T as negative 5, 2. We're going to say E is negative 1, 3. and we're going to say x is at negative 2, 1. So it's triangle text. And I'm going to redo that line here. So there's triangle TEX. So we just graphed it. We want to know what the image of triangle TEX for the glide reflection. So the reflection over y equals negative 2 following the translation 1, 0. So the first thing we have to do is translate it. So translating it, because remember, we have to do the reflection following the translation. So the translation is 1, 0. That means we're going to go right 1, and then we're not going to move. So we're just going to move everything right 1. So E prime would be here. X prime would be there. T prime would be there. So triangle T prime, E prime, X prime will be translated right 1 unit. Now, the next part of this is reflecting over the line y equals negative 2. So there's my line of reflection. We're going to reflect it over that. Now notice that I translated everything this way. Notice that this right here is parallel to the line of reflection. That's what a glide reflection is. Now I'm going to have to extend my graph just a little bit. So now I'm going to reflect everything over, so I'm going to count up. T is going to be 1, 2, 3, 4 away, so 1, 2, 3, 4. That's T double prime. E is going to be 1, 2, 3, 4, 5 away, so 1, 2, 3, 4, 5. And X is 1, 2, 3, 1, 2, 3. So T double prime would be at the ordered pair negative 4, negative 6. E double prime would be at 0, negative 7. And X double prime would be at negative 1, negative 5. And we did that correctly. Please always remember, though, that whenever you have something where you have two transformations, you always do this one first, because this one follows whatever this one is. Our 2 vocab words in this section are isometry. And isometry is a transformation that preserves distance or length. And an isometry, examples would be a translation, reflection, or rotation. Glide reflection. A glide reflection is a composition of a translation and a reflection across a parallel line to the direction that you translated something.